Okay, problem number 5. On this one here, problem number 5, it tells us that we have a body that is moving and it's being described in a function s of t, which is the same as f of t. But this one here is talking about the position function, which is what they usually use is s of t. And so the body's moving along the s-axis or the x-axis on here as a function of time t. So we're going to graph the function s, and then we're going to graph the velocity, and we're also going to graph the acceleration on there, the second derivative and the first derivative. So we're going to be answering some questions on the signs and the value of v and a. So they're giving us that the original function, or what we usually call the d of x, or the d of t in this case, the distance function, is giving us to be a parabola, and they're restricting our time to be between 0 and 5. So we cannot go in past back in time, so that means that our t cannot be negative. So that means we cannot have any negative values, so we have to start at 0, and we're going all the way to 5. Because it doesn't specify on this, I'm just going to give it some units on here so that it's much easier to talk about. And the units that we're going to talk about, that it's moving in centimeters, and then the time is going to be seconds on there. So we're using centimeters and seconds. So here's our first derivative, and our first derivative is going to be and our second derivative on there. So if I actually take the first derivative here, it's going to be our v of t, and that one there is going to be 2t minus 3, and this should be a t right there. The second derivative is going to be our a of t, and when I take the derivative of that, that gives me 2. So once I have those, I could actually graph them, and I did that here. And the purple one is the derivative that we usually, the original function, the distance function. And then we have the green one, which is our first derivative, and then we have that yellow one, which is our second derivative. So let's talk about what we have there. So if I look at this, here is the x-axis, or what we said, the s-axis, and that's describing the position of where we're at. And then this here is the distance away, and this is the time that's moving on. So we're using the s to be in terms of seconds. Let me write that in there. So that is in terms of seconds. And this one here is going to be in terms of centimeters. Okay. So now if I look at that, I'm not happy with that. So if I'm looking at this, let's interpret what this is saying. So here is a body of some particle or whatever, it's moving. So we're moving it along here. And so this is the time that's passing. So as time is passing, the particle is getting closer and closer to 0, which we're going to call h for home. So we're getting closer and closer and closer to home. And then it's actually moving past it, all the way past it to here. And then it stops, changes directions, and then it's getting closer and closer to home, and then it passes home and it keeps going further and further away. So this means that it's getting closer and closer to home. So it's coming from the left-hand side, and then it gets there, and then it goes past, and then we change direction, and then now we're going right instead on there. Okay, so what is actually happening here? So as we're looking and we're getting closer and closer to home, in order for me to change direction, I have to stop, switch directions, and go back in in the opposite direction. So if I look at that, this is what the green one is telling us. Now the negative is just the direction. So I'm going in one direction this way. That's why this is negative. And then I'm heading another direction. I'm going the opposite direction this way. So we could just state that I'm going left here, and then all of a sudden I'm going right there. So I'm going towards home and then back in the opposite direction away from home. And so if I look at this and I'm going down to this part right here, the negative is the direction, but this is the value, the 2, and this one here is, 2.5 or 3. It's getting, that means it's going pretty fast, and then it starts slowing down and slowing down to 0, and that's when it switches direction. So the sign switches and it gets positive and positive, and then it gets going faster and faster away from where we were. And so that's what the first derivative tells us. And then the second derivative is acceleration. So just telling us from here, how are we accelerating? Well, it's a constant acceleration. We're always going to be accelerating at 2. And this is a constant motion here. And so if we look at this, we slow down, we stop, and then we just turn around and keep going, and it keeps accelerating at the same space. The velocity keeps increasing, but we're accelerating at the same place. So let's answer some of these questions. When is the body momentarily at rest? Well, it's momentarily at rest is when we're getting closer and closer to home, past home. Here's where we stop. So this is where it's going to be. So this here, I know I could look at the parabola and use algebra and figure out the minimum and give us the answer, but we're using calculus. So we're going to take this one here. This is where I want it. So the derivative is when the derivative is going to be 0, because I know that the minimum is always 0 in our derivative. So I am going to take that and I am going to use our velocity equation. And so we're going to take the velocity equation v of t. I want the velocity to be equal to 0. So that means I am going to set the velocity equal to 0, not the t, because we're looking at when the time it is at rest, and that's when the velocity is 0. So we put that in there, and then we solve for it, and we get 3/2 seconds. So at 1.5 seconds, you could write yourself a sentence there. I would expect you to, that the body is momentarily at rest at 1.5 seconds. Okay, state the interval of how long the body went in each direction. So when did it go to the left? When did it go to the right? When did it change direction? So if we're going in the left direction to get to home and then pass home in the same direction, we're still going left. And then we're going back, we stop and we turn back around in the opposite direction. So that now means that we're going in the right direction, and then we keep going in the right direction. Okay, so when is the state, when is the time that it's happening? Well, I know that I stop here and I move over there. So the interval in which I'm going in this direction, this is where it is. So you could write a sentence on there. I know that when the velocity is negative, I'm going in one direction, and when the velocity is positive, I'm going into the other direction, because that's what the negative in velocity means, the direction in which you are going. So one of the ways that we could use our derivative here is we could say that when v of t is less than 0, or when v of t is negative, or we could say when v of t is greater than 0, or when it is positive. And so we could write a sentence on here that the interval is between 0 and 1.5 seconds. So that it moves in, let's say, to the left, and then 0, there we go, and 1.5 seconds to 5 seconds, because that's all they measured on there, and then that one there is going to the right. So that's what exactly it means on there. Okay, so the left is heading towards home, the right is heading, and then passing it, and then the right is going towards home and then passing it in the opposite direction. Okay, so you could write that as a sentence as well if you get tested on it. Okay, so when does it change direction? So again, we already answered that up here. It changes direction we could just say changes direction at 1.5 seconds. Okay, very good. When does it speed up and when does it slow down? So again, we could see that it's speeding up and then it's slowing down. So we know that we said before that here it's slowing down and then it starts speeding up afterwards. So it slows down, stops, and speeds up. So we're going to be talking about the time on here by using the velocity. The velocity gives us that information again. So we could say the body speeds up between 1.5 seconds to 5 seconds. And then body speed slows down between 0 and 1/2 seconds. Now, mathematically, if I were to write this interval, I would say point derivative of 3/2, which is 1.5 seconds, because we always want to leave everything in fractions, to 5, and it is included there. Here is because that's where it's actually stopping. It's not speeding up or slowing down. And then this one here, we are including the 0 there, and we are stopping right there to be able to move that out. So here we do not include it. Here we do include it because it keeps going on the outside. Okay, so when is it moving the fastest, the highest speed? The highest speed or the slowest speed is talking about the velocity again. When is the slope the steepest? Or when is not steep? Or actually, when we say it's flat, right? Or the min and max, right? Okay, so when is the body moving the fastest? And if I look at this, the fastest is going to be between the interval of 0 and 5, which is where the restrictions are given to us. It has to be at 5 because here it's not as steep. The steepest is going to go when I move all the way up there. So I know that's going to be the steepest. So what is it? And what is the speed that it's going to be? So it is going the fastest at t equals to 5 seconds. And it's going to be, if we actually calculated, we would do the velocity at 5, and it's absolute value because we want that to be there. And then if I put that into the V2 times 5 minus 3, then that's going to give us 7 centimeters per second. So that's the velocity in which it's going the fastest, when it's moving at 7 centimeters per second, when you put that in there. When is it going the slowest? We already know when it's going to be going the slowest. It's when it's actually the speed is 0. So we know at t is equal to 3/2 seconds, and that's going to be when v of 3/2 is going to equal to 0. Okay, and then the last one, when is it the farthest from home or further away from the s-axis? So this one here is, when is it going to be furthest from the x-axis or the s-axis here, or from home? So here it's not as far away. Here still, all this is not the furthest away on here, but the furthest away that it's going to be is when it's 5 seconds. So when t is equal to 5, the body is 10 centimeters away from home. I'm just going to put that in there if we're counting 0 on there. And so the way that you do that is you actually just put that into the equation on here. And so you would put it in as s of 5. And when we have that, it's going to be 5 squared minus 3, 5 plus 2. And so 25 minus 15 plus 2. And so we end up with, sorry, I wrote down 10 when I meant to write 12. 12 centimeters. Okay, so I'm away from home. And so we are good. Let me get rid of these because it doesn't look like quotations there. Okay, and so that's how you do problem number 5. Very good.